Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 262. Please turn to it. Page number 262, and today is our lesson number 374. Problem number 14 is what we're looking at. Problem number 14 is actually something that we did yesterday. Today what we're going to do is a problem very similar to problem number 14, but presented in a little bit different way. I want to make sure that you are able to handle this one also, in case the problem is presented to you in this manner, as opposed to the one we did yesterday, which is problem number 14, exactly there as it appears in the book. So let's take a look at it. This is problem number 14, but it's not in the book. It's a bonus problem. As I said, it's very similar to problem number 14. Here's the question. It says, what is the greatest possible straight line distance? What is the greatest possible straight line distance between, this symbol is, this means between 2 points on a rectangular box that is 8 by 9 by 12. Sometimes it is called rectangular box, sometimes they refer to as rectangular solid. It doesn't matter what it's called, whether it's called rectangular solid or rectangular box, it doesn't matter what it is. It's a three-dimensional box here. Dimensions are 8 by 9 by 12. Let's draw that box first so that we can visualize it. I need the room obviously, so I'm going to erase this part here. This is something that we learned yesterday. What it says here is that a number is divisible by 3 if the sum of its digits is divisible by 3. The reason I'm pointing it out is because I don't know yet. We may actually need this information again in the solution of this problem. I don't know, but that's what we learned yesterday. I'm going to get rid of it. So let me draw this box here, 8 by 9 by 12. Let's see what we can do. There is our box. There we go. It's about as good as it's going to get. So I'm not going to get greedy. Yeah, a little bit better. Okay. The question here is that they tell you that the box is 8 by 9 by 12, but we don't know where these 8 and 9 and 12 fall. We have no idea. So here we have to play around. We have to play around a little bit here. So let's start with scenario number 1. First scenario. Scenario number 1. There are 3 different scenario possibles here. Scenario number 1. Let's pretend that the floor is 9 by 12. 9 by 12. The floor is 9 by 12, which means this floor right here that you see there, which means this side is 9 and this side is 12. Now just like yesterday, the longest distance that we're looking for, the largest distance that we're looking for, which is the largest straight line distance, is right here, from this edge to that edge, or from this edge to that edge. I'm going to show you here. This is the distance we're looking for. And the way we're going to find out is by looking at this triangle that we just plotted. This triangle is a 90-degree triangle here. Let's give them a name here. Let's call them A, B, and C. Point C is 90 degrees. And just like yesterday, and I keep referring to yesterday's video over and over again, if you have not watched yesterday's video, if you have not watched day number 373, watch it first. It'll be easier to follow this one, because this one is a little bit more complicated. Just like yesterday, the first thing we have to do is figure out the floor diagonal, length of the floor diagonal, which is A to C, which is the length of the floor diagonal, and the floor here is 9 by 12. 9 by 12. So let's find the floor diagonal. Let's find the floor diagonal, which is A to C. So here we're looking at This is our floor, which is 12 by 9, and this is what we're looking for, which is very simple, very straightforward. We don't have to do anything at all. You just have to realize that 9 is 3 times 3 and 12 is 4 times 3. It's a 3, 4, 5 triangle. So the diagonal is going to be 5 times 3. And if you didn't see that, if you don't see that, then you can do the work yourself. Use the Pythagorean theorem and you will find it works out to be exactly 15. 9 by 3, 9 which is 3 times 3, 12 which is 4 times 3, so this is going to be 5 times 3 which is 15. So now we know that AC is 15. Let's put it in our triangle that we are interested in. The triangle that we are interested in is the triangle ABC, which looks something like this. A, B, and C. This is the right angle right here. And we just found out that the distance from A to C, if the floor happens to be 9 by 12, if the floor happens to be 9 by 12, then the distance from A to C is going to be 15. This height here, if this is 9 by 12, then 8 has to be the height. 8 would have to be the height because it's 8 by 9 by 12. So this height is 8. We're almost done. Let's call this distance A to be D for the diagonal, and we're almost done. We apply Pythagorean theorem one more time and find the diagonal. So D squared is going to be 15 squared plus 8 squared, which is 225 times, rather, plus 64. That gives us 9, 8, and 2. So D is square root of 289. Now you have to know your squares. As I always emphasize, that you have to know your squares. We know 15 squared. Where can I do it? I need the room here. We know, I hope you know, 15 squared is 225. 16 squared is 256. You have to know your squares all the way up to 16. All of them, 1 through 16. 1 squared, 2 squared, 3 squared, all the way up to 16. You have to know 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, and 16 squared. Now, if you didn't know 17 and 18 and 19, that's okay. It's okay, because they do not appear very often, okay? But here's what we have to understand. The square of 16 is 256. Also the fact that this ends in a 9. This ends in a 9. So if you were to multiply 17 times 17, that's actually a very good sign. 17 times 17 will have a unit digit of 9 because 7 times 7 is 49. 7 sevens are 49. So let's do it here. I shouldn't have done it this low. So 49, 9, carry 4, 7 plus 4 is 11, and then another 17. And you will see that it is exactly 289, which means the diagonal is 17. That's all. The diagonal is 17. The answer turns out to be A. The question that comes to one's mind, the interesting question that comes to one's mind is that what would be the length of the diagonal if we had used a different floor? Should we look into it? Let's look into it because I'm curious. What would be the length of the diagonal if it turns out, what would be the length of this distance A to B if we use, instead of 12 by 9, let's use a different scenario here. Let's pretend that our floor, the box is sitting in such a way that we have a floor of 8 by 9. If it's 8 by 9, the 12 will end up here. What will be the distance from A to B in that case? Let's find out, shall we? I need the room, obviously. I'm going to get out of your way for a second before I erase everything. So now we're looking at scenario number 2. Scenario number 2, where we have a floor of 8 by 9. Again, first thing we have to do is find the floor diagonal, which is AC, and the floor diagonal, again, we need the room, obviously, we have to erase everything. The floor diagonal in this case would be, this is our floor, 8 by 9, and this is the diagonal we're looking for, which is A to C. A to C, in which case let's call it x here, in which case x squared would be 8 squared, which is 64, plus 9 squared, which is 81. 5 and 14. Looks like x happens to be the square root of 145. X will be square root of 145. Now we figure out the diagonal, we figure out the distance A to B by using the same triangle that we had before, which looks something like this. A, B, C. Remember, B to C now happens to be 12. A to C, we just found out, is square root of 145. The question is, how much is the diagonal? Of course, you should not be surprised to find that the answer is going to be the same. Of course, the answer is going to be the same. For two reasons. First of all, the right answer cannot change just because you're setting up a little bit differently. The answer is what it is. The answer is not going to change. But there is a bigger reason than that, which is it's the same box. You're trying to fit here. What the question here is this. Think of this in this way, okay? The question is this. I have a three-dimensional box. See if I can find a three-dimensional box. If you just give me one brief second, I might actually have something. I can show it to you. It's a three-dimensional box, and the question is, what is the... There, voila. I don't know if you can... There is a three-dimensional box. It's a solid. And if you were to open it, the question is, what's the largest, longest stick that I can put in there? The longest stick that will fit in there from one point to the other, like this, one point to the other, that's what we're talking about, longest diagonal. And that length of the longest stick that I can fit in there is not going to change because it's still the same box. It's just set up a little bit differently. Instead of looking at it this way, maybe you're looking at it this way, or maybe you're looking at it this way. But the longest stick that I can fit in there, in the thing here, is not going to change. Of course, it does not fit right now, but if you open it, and you go from one end, from the bottom end here to this end, it will fit in. You understand? And that length is not going to change because still the same box. It's still the same three-dimensional box that you see in my hand. So that answer is not going to change, and you will see that in a second, that the answer is not going to change. So now we have to look for the D. Let's solve for it. So again, D squared is going to be 140 square root of 145 squared plus 12 squared. 12 squared, of course, is 144, and square root of 145 squared is 145, and we find that it is again 289, and of course that tells you that D is 17. And of course there is a third scenario where instead of using the floor of 8 by 9, we could have used 8 by 12. And that will be the third scenario, which I'm not going to do here. I'm going to leave it up to you to do it. And you will see that you will get the same answer. So the question here is, what's the longest diagonal, what's the longest straight line distance can you have between the 2 points? Well, that's same as asking, where did my pointer go just now? That is same as asking what's the length of this diagonal A to B. And we just found out that it is 17. Okay, bye now.